Hi viewers, in this video we will solve problem 2.56 from the book Heat Transfer J.P.Holman 10th edition. Here is statement of the problem. Water flows on the inside of a steel pipe within inside diameters of 2.5 centimeter. The valve thickness is 2 millimeter. The convection coefficient on the inside is 500 watt per meter square centigrade. The convection coefficients on the outside is 12 watt per meter square centigrade. Calculate the overall heat transfer coefficients. What is the main determining factor for you? Okay, so solutions. Let's write first the given data. Inside diameters, that is ID, and that is 2.5 centimeter. So inner radius of the pipe will be equal to inner diameter divided by 2. Half of the inner dia will give you the inner radius, that is 2.5 divided by 2, so you will get 1.25 centimeter. To convert into meters, divide this with 100, so you will get 0.0125 meter. The wall thickness is millimeters, so the thickness of the pipe valve is millimeter. So you can write in terms of meters, that is x equal to 2 multiplied by 10 to the power minus 3 meter. Convection coefficient on inside the pipe, that is H1, and that is 500 watt per meter square centigrade. And convection heat transfer coefficients at outside of the pipe, that is H2, and it is 12 watt per meter square centigrade. Okay, so this is, let's say, pipe, and its inner radius is Ri. Okay, and then this is the valve of the pipe. Let's say this is the x that show the thickness of the pipe valve. So this inside this steel pipe, there is water flowing in this pipe. So the heat transfer inside this pipe is convection heat transfer coefficient, and that is H1 at inside of the pipe, and outside there is environment conditions, so it is obvious there must be some kind of fluid, so it must be some convection heat transfer outside the pipe, and the outside the convection heat transfer coefficient is H. Okay, so the radius R naught will be equal to R naught, that will be equal to this radius R I inside radius plus this thickness of the pipe valve, that is x. So what is Ri? That is 0.0125 plus 2 multiplied by 10 to the power minus 3. Just add this with each others and you will get outside range, that is 0.01145 meter. If you want to convert into centimeters, then R naught is equal to 1.45 centimeter. This is R naught and this is Ri inside radius. We are interested to find the overall heat transfer coefficient from inside the pipe, because the convection heat transfer coefficient is maximum at inside of the steel pipe. So the surface area inside the pipe, that is equal to 2 pi Ri. So that is equal to 2 pi multiplied by Ri, that is 0.0125, and then surface area. This is the surface area inside the pipe. So it will encounter the Ri or R1. So that is the inside of the pipe. Now this is the R naught from this center to this outside. This is R naught. So if you are taking the area outside the pipe, this is A2, and that will be equal to 2 pi R naught, and it will be equal to 2 pi multiplied by 0.0145. So the area is taken as 2 pi R L. This is 2 pi R naught L, but this L is taken as 1, so I didn't write it previously. So I'm writing now to eliminate the confusions. I hope you understand and you got my point. So this L is taken as 1 because we are solving this problem for unit length. The heat transfer from the center of the pipe is taken place. First, the heat transfer is taken place inside the pipe, and then in that pipe water is flowing. So first is convection heat transfer resistance occur, then thickness of the valve, conduction resistance, and then outside environment, convection resistance, and then finally the temperatures at the outside you will got. It's T1 and this is T2. So here the resistance is R1, where the resistance offered to the heat transfer R2. Here this resistance offered outside the heat transfer, that is R. Okay, so this R1, that is the resistance inside the heat transfer inside the pipe, that is equal to 1 divided by H1 A1, and the R2, this is the heat transfer that is occurs in the wall of the pipe, and that is in the cylindrical coordinates. So we will take the resistance in the conduction's case, it is Ln naught divided by Ri divided by 2 pi k L. So take L length as 1, and R3, that is equal to 1 divided by H2, convection heat transfer outside the pipe, and its area A2. Okay, remember this case the thermal conductivity of the pipe material. So the pipe material thermal conductivity will be given, that is 43 watt per meter centigrade. So now the overall heat transfer coefficients inside of the pipe, so we'll take the inside surface area as well, is equal to 1 divided by total resistance that is offered to the heat transfer, that is R1, R2, R3. So R1 is equal to 1 divided by HA A1 surface area inside the pipe, and plus ln R0 divided by Ri inside radius means Ri R1, this is 2 pi k, plus this R3, that is 1 divided by H2 and A2. Now divide this both side with area A1 inside surface area. So also divide this each terms with A1. So within A1 multiply with this term, so it will be cancelled out with this. So this A1 multiply with this, so here you will get A1. This A1 will also multiply with this, so you get A1 divided by A2. So here it will be cancelled out. You will get overall heat transfer coefficient, that is equal to 1 divided by, so here you will get 1 divided by H1 plus A1 ln R naught divided by Ri divided by 2 pi A plus A1 divided by A2 1 over H. Now just enter the value. So every value is now just enter in the equation. You will get the overall heat transfer coefficient. 500 plus 1 divided by what is A1, that is 2 pi, R1, that is 0.0125, that is 1.45 divided by 1.25 divided by 2 pi multiplied by 43. A value for the steel pipe is 43. So this 2 pi will be cancelled out with this 2 pi plus A1, that is 2 pi multiplied by 0.0125, then divide with A2, that is 2 pi multiply 0.0145 multiply 1 divided by H2, and that is 12. So this 2 pi will be cancelled with this 2 pi. After simplifications on calculator, you will get the value for each one, that is 2 multiplied by 10 to the power minus 3 plus 4.3145 multiplied by 10 to the power minus 5 plus 71.84 multiplied by 10 to the power minus 3. So after simplifications, you will got the answer for the overall heat transfer coefficient, that is 13.54 watt per meter square centigrade. And that is our final answers. I hope you understand. If you still have any confusion, you can ask in the comment section. If you haven't subscribed my channel yet, subscribe.